name is Qing Xiangming. My metric number is 08 DEP 21F 2002. Introduction. The topic is application of basic operation of vector and scalar quantities, including their use in solving civil engineering problems. The topic also explains the method for determining angle between two vectors as well as the characteristic of triple vector scalar product and vector product. Vector expression. A scalar quantity is a physical quantity that has magnitude but no direction, while vector quantity is a physical quantity that has both magnitude and direction. Scalar. Every scalar quantity is one dimension. Vector and quantity can be 1, 2 or 3 dimension. Scalar quantity has magnitude but no direction. Vector quantity has both magnitude and direction. Any change in scalar quantity is the reflection of the change in magnitude. Any change in vector quantity can reflect either change in direction or a change in magnitude or change in both. Any mathematical operation carried out among two or more scalar quantity will provide a scalar only. However, if a scalar operates with a vector, then the result will be a vector. The result of mathematical operation between two or more vectors may give either scalar or vector product, or summation or subtraction.
Hi, my name is Nurwahida binti Ismail, matrix number 08 DEP 21F2013. So, scalar dot products of two vectors. Scalar dot products will be A dot B equals to x1 times x2 plus y1 times y2 plus z1 times z2. So, scalar dot products will be used when we need to find angle between two vectors. And when this happens, we will use the formula cos theta equals to A dot B over modulus A modulus B, which is modulus we will represent magnitude. And then scalar dot products also have three notation. First, Cartesian notation. Second is coordination notation. And the third one is matrix notation. So now we will take a look at the example for in Cartesian notation. So given S equals to I plus 2j minus 7k and M equals to negative 2i plus k. So first we need to calculate S dot M. So we will use the number in the equation, we will be multiplied for the other equation that have the same alphabet. So 1 times negative 2 plus 2 times 0, because for M equation there is no j. And then plus negative 7 times 3. So the answer we will get negative 23. So the second one is we need to find angle between vector S and vector M. So in this question, it asks us to find the angle between vectors. So we will use the formula of cos theta equals to S dot M over magnitude of S and magnitude of N. So here we already got the S dot M equation, which is negative 23. So the magnitude of S will be square root of 1 squared plus 2 squared plus negative 7 squared. So the answer for magnitude S is square root of 54. And for the magnitude of M, we will get square root negative 2 squared plus 0 squared plus 3 squared. And the answer will be square root of 13. So in equation, we will get cos theta equals to negative 23 over square root of 54, square root of 13. And then we will get cos theta equals to negative 0.868. Then we will bring cos to right side, and then it will be theta equals to cos negative 1 times negative 0.868. And the answer we will get theta equals to 150.23 degree. So the next example we will be in matrix notation. So given T equals to matrix formation 1, 2 and negative 7, and Y equals to matrix form 2, negative 6, 1. So first we need to calculate the dot product, which is T dot Y. So same like the before in the Cartesian notation, just multiply the number that have the same coordinate. So the answer we will get negative 17. Second, we will need to find the angle between T and Y. So we use the cos theta equals to T dot Y over magnitude of T, magnitude of Y. So for this question, the magnitude of T we will get square root of 54, and for magnitude of Y we will get square root of 41. So put it in the formula and we will get cos theta equals to negative 17 over square root of 54 square root of 41, and we will get cos theta equals to negative 0.31, and bring the cos to the right side, and we will get theta equal to cos negative 1 times negative 0.361, and the answer we will get theta equals to 111.16 degree. Next, vector cross product of two vectors. Vector cross product will be used when we need to find the perpendicular between two vectors, and we need to calculate as determinant 3 by 3. So determinant 3 by 3 is the unknown we will be in the first line, and the equation 1 we will put it in the second line, and equation 2 will be in the third line. Also for vector cross product, we will put the answer in the Cartesian notation form. So we can see here A equals to x1 plus y1 plus z1, and B equals to x2 plus y2 plus z2. So the cross product of A cross B will be I, j, k, x1, y1, z1, x2, y2, z2. And then, same like we find the determinant in the matrix, in bracket of I, y1 times z2 minus z1 times y2. And then, minus it with bracket of j, which is x1 times z2 minus z1 times x2, and plus it with bracket of k, x1 times y2 minus y1 times x2, and the answer we will get in the form of I, j and k. For example, in the vector cross product, we will look here. If B equals to I plus 3j minus 4k, and C equals to 2I minus 2j minus k. So first we need to find vector that perpendicular to both B and C. So look at here, it mentioned that perpendicular. So we need to use the cross product method. So B cross C equals to I, j and k. The determinant 3 by 3, I, j and k. I 1, 3, negative 4, 2, negative 2, negative 1. So put it in the bracket of I, minus bracket of j and plus bracket of k. So we will get bracket of I, negative 2, negative 6, minus bracket of j, negative 1 plus 8, plus bracket of k, negative 3 minus 8. And the answer we will get negative 8i minus 7j minus 11k. And the second one, we need to prove that vector B is perpendicular to vector C. So when we say that prove vector B perpendicular to vector C, we will use the dot product. So B dot C equals to 1 times 2 plus 3 times negative 2 plus negative 4 times negative 1. And then we will get the answer is 0. When the answer is 0, therefore vector B is perpendicular with vector C.
Hi, Assalamualaikum. My name is Muhammad Alif Amin bin Kamarudin. My metric number 08DEU21F1116. Conclusion: vector is very important in our daily life and in an engineering mechanic to represent quantities that have both a magnitude and a direction. Many engineering quantities such as force, displacement, velocity, and acceleration will need to be represented as vectors for analysis. Okay, thank you.